Hey there everybody, welcome back to my channel if you are a returning subscriber, or welcome to my channel if you're new. So today we have the final part 3 of our Systems of Equations chapter series that we've been doing. So if you haven't already watched the videos for elimination and substitution, be sure to do that. I'm going to link that all in the description below. Also, please keep in mind the registration link for our June SAT crash course, as well as our SAT math workbook, No BS SAT math. All of that information will as well be linked in the description down below. So without further ado, let's jump into today's video. All right, so first let's begin here with practice test 1, question number 19. So what we're going to want to keep in mind when it comes to questions involving systems of equations is that we're going to need to set up typically 2 different equations. One that usually involves money of some sort and one that typically involves some sort of quantity. So let's check out number 19 and I'll show you how it's done. So they tell us in the problem that the food truck sells salads for $6.50 each and drinks for $2 each. The revenue for 209 salads and drinks, so just for everything that they sold, 209 of whatever that was, in one day was $836.50. How many salads were sold that day? All right, so luckily we do have a calculator for this question, thank goodness. All right, so let's call S the number of salads, and let's call D the number of drinks. Okay, so we know then that the number of salads plus the number of drinks has to equal 209, as per this part right here where they told us they sold in total 209 salads and drinks. So this is our first equation, so I'll mark that with 1. So this is the quantity equation, so I'll just write that on the side over here. Like I said, there's usually a quantity and then a money equation on the SAT math. So here's our quantity. We'll write the money equation down below. So we know then when it comes to salads that each salad costs $6.50. So we know that $6.50 times the number of salads, S, plus $2 times the number of drinks, D, is equal to the total that they sold, which was $836.50. Okay, so again, we had said in a prior video that when we have all of the variables on one side right over here, and then we have all the numbers on one side over here, we're going to want to do the elimination method. So in order to eliminate, as we said, we need in 2 equations for that same variable to have the same number in front of it, but different signs, so that when we add the 2 equations together, that variable is going to end up canceling out. So I think that dealing with 2 is probably a little bit easier than $6.50. So let's multiply the top equation here by -2 so we can cancel out the number of drinks, D. So we're going to multiply each of the terms inside here by -2. So the top equation then, so I'm going to write 1.0, so we know it's the first equation revamped, becomes -2s minus 2d is equal to -418. All right, so just as we wanted, when we add these 2 equations together, we're going to see that the d variable is going to cancel out because it's +2 in the top and -2 on the bottom, so that cancels out. We're left then with 450s is equal to, let's grab this calculator, so 836.50 minus 418 gives us 418.5. So now we'll divide both sides by 4.5 to get then that S is equal to 93, meaning they sold 93 salads, choice B that day. All right, let's check out number 19. So again, we're going to need to generate 2 equations. So in this case, we're not talking about money. We're talking about the number of hamburgers and fries and the calories associated with each item. So let's go ahead and set up our 2 equations. So the first equation here, we know that each hamburger has 50 more calories than each order of fries. Okay, so let's go ahead and reflect that. So H will obviously be hamburger, F will obviously be fries. So the hamburger can be represented in terms of the calories of the hamburger as the fries plus 50. So let's just write this down so we know. So I'll write that up here. H is equal to the number of calories of the hamburger. And then F will be equal to the number of calories of the fries. All right, so we represented that H, the number of calories of a hamburger, is the number of calories in fries plus 50 additional calories. So that's our first equation. And then in our second equation, they tell us right here that 2 hamburgers and 3 fries have a total of 1,700 calories. So 2 hamburgers plus 3 fries has a total of 1,700 calories. Okay, so in this case, as we said, whenever we have one variable in terms of another, like we do right here, we're going to go ahead and replace this H with F plus 50. We're going to use substitution to solve this question, not elimination like we did for the last problem. Because we do not have all of the variables on one side, all of the numbers on the other. We very easily have one variable in terms of another, so substitution is going to be our go-to. All right, so we get 2 times F plus 50 plus 3F is equal to 1,700. So that becomes 2F plus 100 plus 3F equals 1,700. 5F plus 100 equals 1,700. We'll subtract 100 then from both sides. We get that 5F is equal to 1,600. So we'll divide both sides then by 5 to find that F is equal to 320. However, they want to know how many calories a hamburger has, so we're going to have to take this, the fact that F equals 320, and just plug it back into our top equation here. So H is equal to 320 plus 50, so the hamburger has 370 calories. Alrighty, number 11 is a little bit different, but still the same kind of idea applies. This kind of reminds me of in substitution when we said we had 2 equations where it was y equals something and y equaled something else. We could go ahead and set those 2 things that y was equal to each other. That's exactly what this question is asking. So they tell us here that B and C represent the price per pound of beef and chicken. They ask us what was the price when the beef was equal to the chicken's price. Okay, so what that means then is that we're going to set what B is equal to. We're going to set that equal to what C is equal to here because we want it when it's equal. So let's go ahead and set them equal. So we get 2.35 plus 0.25x is equal to 1.75 plus 0.40x. All right, so we're going to want to move all the numbers to one side, all of the variables to the other side. So let's subtract 0.25x. We get then that 0.15x is being added to 1.75, and that's going to be equal to 2.35. So let's subtract 1.75 on both sides. Let's see, 0.25 plus 0.35, that's going to be 0.60 is equal to 0.15x. We don't have a calculator here, but this is basically just 60 divided by 15 technically. So we know then that x is equal to 4. So now that we figured out that x is equal to 4, we can go ahead and take that up here and plug that into either of these 2 equations. I think the top one's going to be easier because 0.25 times 4 is just $1. So let's go ahead and use that. So 2.35 plus 0.25 times 4 is going to be 2.35 plus 1. So that's going to be equal to 3.35, which makes our answer then choice D. Alrighty, and let's check out one final problem then on how to deal with word problems with systems of equations. Number 6 right here. So they tell us here an online bookstore sells novels and magazines. Each novel sells for $4 and each magazine sells for $1. This is very similar to the first problem we looked at where you're going to have like the number of novels and magazines and then the price associated with each. So we're going to again need to set up 2 equations. All right. So our first equation, we know that they sold 11 novels and magazines in total. So the number of novels plus the number of magazines is equal to 11. So we'll just write over here that N equals number of novels, M equals number of magazines. All right, so that's our first equation. Now let's write our second. So we know that each novel is $4, so 4N plus each magazine is $1 plus N is equal to 20 because that's how much they made that day. All right, so again, we have all the variables on one side, the numbers on the other, so we are going to be using, again, the elimination method to solve this problem. So let's go ahead and do that. So what we can do then, first of all, let me just rearrange. Whoopsies, this is actually supposed to be plus M, not N. All right, letters look the same. All right, so let's go ahead and take this top equation here. We can just simply multiply it by a negative because if we could see, we have a positive M here and a positive M here. So if we make the top one a negative M, that's gonna basically solve this for us. So on the top, I'm gonna again call it version 1.0. We get negative N minus M equals negative 11. So now we're gonna see that the M variable here eliminates itself. We get 3N is equal to 9, so N is equal to 3. So she purchased 3 novels that day, choice B. All right, so that's basically how we deal with these problems. We want to set up 2 equations and then either use substitution or elimination in order to find the desired quantity that they are asking for. Thank you so much for watching. Hope that you enjoyed and learned a lot about systems of equations and how those types of questions will appear on the SAT math section. Make sure, guys, to check out the registration link below for our June SAT crash course, where we cover all 4 sections of the SAT, reading, writing, and language, and both the maths, as well as the link for our SAT math workbook, all linked down below. Thanks so much, guys. Take care and have a great rest of your day.